Yeah, we're looking at titration, redox titration for alternative B chemistry practical. All right, it's taking place tomorrow. I wish you guys all the best. A1 in all your exam. Now, historically, we look at what has happened in the past in terms of questions that have been set on this topic. 2016, 18, 2019, 22, 23, and now 26. 6 years. Wow. This 6 years is enough for you to cover your A1 in chemistry. Let's quickly dive into what I have for you today. All right. Theoretical value of volume of the supposed acid, as we all know, but here we don't have acid. We don't have. It's not like acid and base when it comes to alternative A. Okay, this one is a redox type of titration. So we have theoretical value for VE. So I'll quickly run down what we have for this WAEC practical. So the D given is oxalic acid as HUC2O4.2H2O. Of course, is an hydrated salt. So oxalic acid is very hydrated. I hope you know what that means. All right, the E we have got our E there. Our E is KMNO4. All right, now the mass of the oxalic acid given is 6.3 gram per dm³, while the mass of KMNO4 given is 3.1 gram per dm³. Now look at it. Originally, we normally have our acid in the breath and our base in the pipettes, which are going to titrate it. But there's a little twist in this particular practical. So your D is your oxalic acid, while your E is your KMNO4. So when you are labeling it, know what you are doing. So your volume of D now will be the volume of the oxalic acid. Okay, and in this particular practical, your volume of D is not going to be inside the breath. Your volume of D is going to be inside the pipette, because there are a lot of things you are going to do on that, while your volume of E will serve as the supposed acid. So let's look at your calculated value for the acid. So let's look at the molar mass for the hydrated value. When you calculate that molar mass, you are going to have 126 gram per mole. When you look at the molar mass of KMNO4, you have 158 gram per mole. Look at the complete balanced chemical equation, redox equation. Of course, from the chemical reactions of the oxalic acid and the permanganate, you're going to have a redox reaction of this. It shows that the mole ratio of the oxalic acid to the mole ratio of the permanganate is going to be 5:2. That's 5 moles of oxalic acid against 2 moles of the permanganate. So let's quickly look at the molar concentration of this particular reaction. Of course, this one is majorly for tutors. As a student, you don't need this one in your exam tomorrow. Okay, tutor, just pay attention to see how do I guide my students. So to calculate our CD, condition in mole per dm³ of our D will be the 1 kg per dm³ over molar mass. That will be 6.3 divided by 126 will give us 0.05 mole per dm³. It must always be to 3 significant figure. While for E, we're going to have 3.10 divided by 158, which give us 0.1019 0.0196 mole per dm³, which also to 3 significant figure. Now the volume of the oxalic acid now, okay, the volume of the oxalic acid, I beg your pardon, supposed to be the volume of your KMNO4. Okay, let's clearly do that. Why we are using CdVd over CeV equals to ND over what? and E. So your CD is 0.05 given, while your VD now is 25 because that's what you're going to pipette, and then you warm. Why this? Your conc of E is 0.0196. We are looking for the volume of E now. That's volume of KMnO4 in that reaction. So when you do that with your ratio, you are going to have final answer to be 25.50 cm3. So that's going to be your volume of E. This is a theoretical calculation. You can get higher volume, and you can at the same time get a lower volume depending on your experiment is tomorrow. Okay, it's a final quick reaction, a final revision for all the students. Look at the question 1. D is a solution of 0.05 mol per dmq of H2C2O4. Y is a solution of KMnO4. The concentration is not known. All right, you have to put E into the burette, then you pipette D into the flask and add about 10 cm3 of dilute H2SO4. Heat the mixture. When you heat the mixture, while it's still hot, then you titrate your D now, okay, with your E inside what? Inside your burette. Of course, you are going to now calculate the average volume of your E. Do you get that? So your E now is serving as what I call it our VE. So for this particular, I'm going to be using this table. This is how your table should look like. Even though you are not using this particular value, no problem. Make sure you have your concordance value. Look at my concordance value 25.50 plus 25.50 divided by 2. If you are using 3, make sure the difference is plus or minus 0.1. Okay, why I like this so much? You want to have your free of charge mark 10 marks on the table. Okay, we're going to be using this table for the O4 question, so take note of that. Question number 1, let's class from the result and information provided, calculate the concentration of E mol per dmq. So going back to the questions, we're not giving the value of what? Of E in mol per dmq. So we can use this formula. You can see the formula here. CdVd over CV equals to ND over NE. Remember from the balanced chemical equation, our mole ratio of the oxalic acid to KMnO4 is this. So when you substitute correctly, okay, you have the value to be 0.0196 of what? Of E. Please remember we are calculating for E of what? Of E. Please take note, don't make that mistake tomorrow. All right, now we are to calculate the concentration of E now in gram per dmq. This formula is very common. Concentration of E in mol per dmq equals to conc of E in gram per dmq over molar mass. Our molar mass is already calculated. Remember to be 158 multiplied by our concentration will give us 3.10 gram of E. What is the volume evolved when amount in mole is equal to CV over 1000, which is conc of D in mol per dmq times volume of D divided by 1000. Conc of D is 0.05 multiplied by 25 of D divided by 1000 give us what? 0.0125 moles of D. Now from the balanced chemical equation, we realize that 5 moles of D will produce what? 10 moles of what? Of the CO2 from the balanced chemical equation. Remember that formula that says N is equal to V over 22.4 dmq. Remember, right? So your volume will multiply by your moles. So we are going to have 22.4 dmq multiplied by 10. All right, so when you cross multiply, you're going to have 0.0125 multiplied by 224 divided by 5. Everything gives us was 0.056 dmq of C2. Yes, of C2O42 minus. Did you get that? Let's proceed. What is the mass of C2O4 ions in 500 cm³ of C. 500 cm³ of C. So the same formula will be used. Number of moles is equal to CV over 1000. Of course, but your mole can also be substituted with mass over molar mass. Mass over molar mass. We are looking for mass. So my mass over molar mass, my molar mass of C2O42 minus will be 88. So I'm looking for mass. Just a correct substitution here. You have for final answer to be 2.20 gram of C2H, beg your pardon, C2O42 minus. Let's proceed to question number 2. Did you get that before me? Make sure you do it very well. Because WAEC, you can test anything. Understand? Question number 2. This is a solution of 0.05 mole per dmq of H2C2O4. While E is 0.0196 mole per dmq. You have been given the two concentration in mole per dmq. So let's just look at the question ahead. From the information, calculate the amount in moles. Now look at this question. There's a twist in this question. There is no equation, number one, and you are only giving the oxalic acid. You are not giving the KMNO4. So it's suggesting something that probably I'm going to be calculating the mole ratio of the oxalic acid to KMNO4. A good student should quickly realize that. So you bring in your method, amount in mole equals to conc mole per dmq times volume divided by what? 1000 for both oxalic acid and permanganate. So let's quickly run that to see for the oxalic acid. Look at it here, we have 0.0125. Why for the permanganate we have 0.00499. Okay, if you convert that, you're going to have 0.0000500 moles. But we can still use that anyway. So this for oxalic acid, this is for permanganate. Now you're going to put them in ratio format. Then you divide by the smallest. This is actually the smallest. Dividing by the smallest, you have, okay, look at it. If you divide 0.0049 divided by itself, you are going to have 1. When you divide 0.0125 divided, you are going to have 2.5. Of course, in chemistry, you cannot have a whole number to be decimal, right? So you have to multiply by a number that will give us what? Whole number. So if the appropriate number is multiplied through by 2, you're going to have 2 times 2.5 give us 5, and 2 times 1 give us what? 2, which shows the ratio of your supposed oxalic acid to permanganate, 5:2. D is prepared by dissolving 10 grams of H2C2O4 and NaCl to 1 dmq, while E is this. So when we look at that, look at our balanced chemical equation. From the result and the information provided, calculate the concentration of H2C2O4 in mole per dmq, concentration of H2C2O4 in gram per dmq, and concentration of this one in gram per dmq. Then the mixture of the H2C2 in the mixture and NaCl in the mixture. It's a very simple solution. Now our mixture is what? Is 10 grams per dmq of H2C or the oxalic acid and sodium chloride. That's our mixture. Then look at our value. Then when you calculate your CD, you're going to have 0.05 mole per dmq. Did you get that? I expected you to be doing it the way I'm doing it, so that tomorrow you will know what you are doing. All right, when you calculate conc in gram per dmq, just change it to gram per dmq. Our molar mass is already 90. You can see the way it's being worked out. So everything will give us for 4.5. So this is the gram of the oxalic acid. Now, what is now the concentration of sodium hydroxide or sodium chloride? Remember, they are mixed. 10 is the mass of the mixture. When you remove 4.5 from it, of course, you're going to have 5.5. So 5.5 is the gram or the mass of sodium chloride in the mixture, while 4.5 is the gram of H2C2O4. Now, what is percentage of H2C2O4 in the mixture? That's percentage purity is going to be your 4.5 over the total multiplied by what? 100. Just like the axis calculate your purity, that's pure over impure, multiplied by 100. So our 45% is the purity value of this experiment. For sodium chloride, it's going to be the mass of sodium chloride over the total multiplied by 100. It give you 55. Or if you don't want to stress, very smart student can say 100 minus 45 will give us what? 55%, which actually give us the mass of impurity. All right. Question number 4. Please take note of this question. It's not the least question, but a powerful question. D is a solution of 6.3 gram per dmq of H2C2O4 dots. That's H2O. Is a solution of 0.019 of KMnO4. Now, when you see something like this, definitely you'll be asked to calculate the value of X. So prepare for that. Conc of D mole per dmq, conc of D in gram per dmq, value of X, and water of crystallization. Very simple. We have been given the values of 6.3. That's for this. You go through the same route for calculating our CD. Then you have this as condition of H2C2O4 oxalic acid in mole per dmq. So let's take it to gram per dmq. Also calculate the molar mass to be 90. Then you cross multiply. You have 4.5 as our gram per dmq of D. What is now the value of X? The value of X, what you calculate value of X, you want to get the molar mass of the hydrated salt. And in doing that, you have been given 6.3 gram per dmq. So divide by what? By 0.05 mole per dmq. You have 126. So 126 is the molar mass of the hydrated salt. So equating it to 126, you have the value of hydrogen to be what? 1 times 2, 1 times 2 plus 12 times 2 plus 16 times 4 plus x18 equals to molar mass. That's 126. So if you do all of that, if you calculate all these things together, you have your 90 plus 18s equals to 126. So if you do all of that, you have your 2. So your equation becomes H2C2O4.2H2O. Did you get it? What is now the percentage of water of crystallization? Of course, mass of hydrated minus mass of anhydrous over hydrated. So 6.3 minus 4.5 divided by 6.3 times 100. So the percentage of water crystallization will give us 28.5. The percentage of water of crystallization will give us 28.57%. I wish you good luck tomorrow. All the best in your exam.